Welcome back, ladies and gentlemen. We are going to continue today with talking about triangles congruence and talk about different ways that we can prove that. Okay, so quick little overview. Yesterday, the previous lesson, depending on when we watch this video, we talked about in order for triangles to be congruent, you had to have every pair of corresponding side, okay, be congruent. So like 1, 2, 3, 1, 2, 3. And you also had to have every pair of corresponding angles, this is super tiny, be congruent as well. Okay. Oh no. Are we updating right now? That's funny because I don't update. I've been doing that for like 2 years. So hopefully you guys are cool and comfortable with the fact that the tick mark means the sides and the little like half semicircles inside there are your angles, okay? Well, what if we don't have everything? Can we still prove triangles are congruent? Well, the answer is that we can, and we have a bunch of things that we can use to prove it. We have these postulates, okay? So today we're going to talk about proving triangles congruent by SSS and SAS. Now, as I mentioned before in class, mathematicians are very lazy. Okay, in terms of they don't want to write things out. We like numbers more than we like words. So, SSS stands for side, congruence postulate. And here we go. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. So here, let's take an example. If I have triangle MNP, okay, and I have another triangle, QRS. Well, that's a really badass. Yikes. Okay, Superman would not be impressed by that one. Maybe Batman, but alright. If I know that side MN is congruent to QR, so MN to QR, and I know that side NP is congruent to RS, boom, boom, and PM is congruent to SQ. If you can prove that those sides are congruent, you have enough information to say that this triangle is congruent to that triangle. Okay, so how is that different than up here? Well, I don't need the angles. Okay, so the cool part is if I just have the sides, I have enough by SSS to prove it. All right, so this is my SSS. This is our first big one. This is the easiest one. That's a difficult level of like say 1. Okay, because it's really easy to tell if all 3 sides are the same. Well, okay, what if I don't have all 3 sides? Oh no, okay. Well, I might have something called side angle side, SAS, congruence postulate. Well, let's take a look at this one. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. What does included mean? Well, included means in between. So, okay, here's a triangle, here's a triangle. I'll try and draw these a little bit better. P, Q, S, W, X, Y. All right. If PQ is congruent to WX, bam, bam. Okay, and angle Q is congruent to angle X. And side QS is congruent to side XY. Now, this is going to take us a while to get used to. If you have side directly followed by an angle, directly followed by a side. If you have SAS on both triangles, you have enough information to say triangle PQS is congruent to triangle WXY. Alright? We're going to have to slow things down and get good at this. It has to go in order. Okay? So it needs to go bam, 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 directly next to. Alright? So again, included means in between. Alright. This is my SAS. Okay. So down here, using congruence postulates, all right, this is pretty simple, but you have to look for the pattern. It's all patterns, okay? So if I want to prove that triangle DEF is congruent to triangle JKL, I'm looking over at the pictures here. So I'm noticing, all right, they're giving me a tick mark. They're giving me 2 tick marks. 3. Okay. Oh, 1, 2, 3. Those tick marks represent sides. So I have one side, second side, third side. Well, if I had to pick between the 2, I'm hoping this is pretty obvious. This would be my SSS postulate. Okay, and that's all we're doing is we're picking which postulate we can use in order to say they're congruent. Okay, simple, but you have to notice the pattern. Okay, all right. So we'll up the difficulty a little bit. We're trying to prove that triangle ABC is congruent to triangle DEF. Well, over here it's a little harder to see. Sorry. Here's one tick mark. One tick mark. Here's two tick marks. There's two tick marks. And in between these two sides, directly in between them, I have an angle. So I've got a side, followed by an angle, followed by a side. What's probably going to come up real soon, too, is if you guys are wondering, somebody might be going, well, can I go like this, side, all the way around the side, then my angle? See how I'm skipping this angle and this side to do that? You can't skip, so you have to go in order. All right? Oops, sorry, I keep knocking things over. So this is my SAS postulate. And we're all good. Okay. All right. So number 3, I'm going to up the difficulty just a little bit more. We're going to prove that triangle SYT is congruent to triangle WYX. So over here I have two triangles. Oh no, I've got a side, and I've got a side. Then I've got the two tick marks that are congruent. But that's all I've got. Like, oh no. Can you guys see angle 1 and angle 2? You just did an amazing job on this a couple of reviews not too long ago with something called vertical angles. Now, what vertical angle states is that angles opposite of one another have to be the same. So question for you guys. Do I know what angle 1 and angle 2 measure? Absolutely not. But I do know that whatever this is, it has to be the same as this. If this is 30 degrees, that must be 30 degrees. Well, whammy, okay? Whammy. Okay? We've got it. Side, angle, side. SAS. So I'm hoping that you guys can see that, like, yes, this is pretty simple, but we're going to slowly up the difficulty a little bit to kind of get you guys where you need to be. Okay? Alright, on to the back. Okay, so here's the thing about the back. I'm going to show you guys, alright, well, we're going to work our way through this. We're going to decide if enough information is given in the diagram to prove triangle is congruent. If there's not enough information, you just, if there is enough information, you state the congruence postulate. If there's not, you just write not enough info, okay? So just a heads up, if I use NEI, that stands for not enough information. Okay. Yeesh. Ends are bad too. Okay, so prove that these triangles are congruent. Well, I've got a side right here, I've got a side right there. Now, can you guys see how these triangles are back to back? WZ is shared by both triangle XWZ and by triangle YZW. So this side right here, okay, we know that WZ is congruent to WZ because of reflexive property. Okay, property, I guess I should spell it. Now here's the other thing. If I have these sides parallel, okay, so then what I've got is these sides are parallel, and I can use alternate interior angles that are going to be congruent. So I'm going to call this angle 1, I'm going to call this angle 2. Angle 1 is congruent to angle 2 by alternate interior. Thank you. Ooh. Jenny's a superstar. Okay, so now I've got a side, an angle, and a side. So we can prove that these two triangles are congruent by SAS postulate. Alright, so what we're going to do then is take a look at our next one, right? Okay, so SAS postulate, good. Part B, prove that triangle PQT is congruent to triangle STR. Now, this is a very deceiving problem. We've got the side here, QT. Get it, QT? That's funny. All right. You've got the side RT. All right. They're congruent. So we have one pair of sides. We have PT and then TS. And you might be very inclined to say that angle 1 is congruent to angle 2. But please be careful. these are not vertical angles. Okay? Vertical angles have to be completely straight lines. And if I were to take a ruler, okay, you'll notice that if I put a ruler straight across, it's not straight. Okay? So like it needs to be going this way across in order for that to be vertical. So, luckily enough, this one is NEI. Please don't get trigger happy with this and put NEI for everything, because I've noticed that in the past, and I just don't want you guys to fall into that trap. Finally, prove triangle CMG is congruent to triangle ZMG. I have two triangles back to back. Okay, so CMG is right there, ZMG. I've got the first side CG and GZ. I've got the other side CM and MZ. Okay. So, the last thing I can say is they're back to back. All right. So MG is congruent to MG. And that again is our reflexive property. Well, good news, everyone. Okay. Now I've got what I need because I have a side, side, side. So I have my S postulate. Okay. So absolutely wonderful. Very nice job. What have we learned so far? You learned two postulates. We have SSS. We have SAS. We're going to learn a few more in class, okay? And we're going to add them to our toolbox, which we can use in class to prove triangles congruent. Thank you for all your hard work. As always, keep up the good work and good luck. We're all counting on you.